use Wireshark to view network traffic topology, router with internet connection and your local area network. Wireshark is a software protocol analyzer or packet sniffer application used for network troubleshooting, analysis, software and protocol development, and education. As data streams travel back and forth over the network, the sniffer captures each protocol data unit (PDU) and can decode and analyze its content according to the appropriate RFC or other specifications. Required resources, a PC and additional PCs on local area network. Capture and analyze local ICMP data in Wireshark. Retrieve your PC interface addresses. You will need to retrieve your PC IP address and its network interface card NIC physical address, also called MAC address. In a command prompt window, enter ipconfig/all. Okay, command prompt ipconfig/all. Okay, and maybe you are using wireless LAN adapter Wi-Fi, but in my case, I'm using Ethernet. But in my case, I'm using this Ethernet adapter. In my IPv4 address is 192.168.170, and subnet mask 24, 255, 255, 255, 0. And this is the physical address 54AB3A5B AD04. Ask a team member or team members for their PC IP address and provide your PC IP address to them. Do not provide them with your MAC address at this time. Start Wireshark and begin capturing data. Okay, navigate to Wireshark. This double-click the desired interface to start the packet capture. Okay, maybe you are using the Wi-Fi adapter, but in my case is Ethernet adapter, and double-click here. Okay, and also make sure the desired interface has traffic. Okay, this is the traffic. Okay, this peaks, and double click here. Information will start scrolling down the top section in Wireshark. The data lines will appear in different colors based on protocol. Okay, and this information can scroll by very quickly depending on what communication is taking place between your PC and the LAN. We are only interested in displaying ICMP ping PDUs. Type ICMP in the filter box at the top of Wireshark and press enter. Or click the apply button, the arrow sign. Okay, this is the filter up here. Type ICMP, ICMP, and enter or press this button, the arrow button, to view only ICMP. This filter causes all data in the top window to disappear. Okay, but you are still capturing the traffic on the interface. Navigate to a command prompt window and ping the IP address that you received from your team member. Okay, remember my IP address is 192.168.170, but the IP address of my team member is 192.168.150. So ping to that interface, 192.168.150. Then press enter. 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 Okay. 1, 2, 3, 4 pings. And on Wireshark, 8 lines. Okay, very nice. If the PC of your team member does not reply to your pings, this may be because the PC firewall of the team member is blocking this request. Okay, disable your firewall. Okay, type firewall and go to Windows Defender Firewall and turn Windows Defender Firewall on or off and turn off in both cases to permit the ping. Stop capturing data. Okay, this is the button, the red square. Stop. Examine the captured data. Okay, examine the data that was generated by the ping request of your team member PC. Wireshark data is displayed in 3 sections. 1. The top section displays the list of PDU frames captured with a summary of the IP packet information listed. Okay, this is the top section. Okay, top section. 2. The middle section lists PDU information for the frame selected in the top part of the screen and separates a captured PDU frame by its protocol layer. Okay, this is when you select one line at the top, the detail is in the middle section. So this is the middle section. And 3, the bottom section displays the raw data of each layer. The raw data is displayed in both hexadecimal and decimal form. And this is the top, the bottom section. Okay, and hexadecimal here, and ASCII here. Okay. Click the first ICMP request PDU frames in the top section of Wireshark. Notice that the source column has your PC IP address and the destination column contains the IP address of the teammate PC that you pinged. Okay, select the first. The source is your IP address, and the destination IP address is the IP address of your team member. With this PDU frame still selected, in the top section navigate to the middle section. Click the plus sign to the left of Ethernet 2 row to view the destination and source MAC address. Okay, select at the top section the first line, and on the middle section expand the Ethernet line. Click here, and you have the destination and source MAC addresses. Does the source MAC address match your PC interface? Okay, remember my MAC address is this. (54AB3A5B AD04), and the source is (54AB3A5B AD04). Yes. Okay, the answer is yes. Does the destination MAC address in Wireshark match your team member MAC address? Okay. Now ask your team member MAC address, and this is D07E35E851B6. And the answer is yes. Okay. ARP option A, to verify the team member MAC address, and is this 1.50 07E35E851B6. Okay, this is the MAC address of your team member. How is the MAC address of the PNet PC obtained by your PC? Okay, the MAC address is obtained through the ARP request. In the preceding example of a captured ICMP request, ICMP data is encapsulated inside an IPv4 packet PDU, IPv4 header, which is then encapsulated in an Ethernet 2 frame PDU, Ethernet 2 header, for transmission on the LAN. Capture and analyze remote ICMP data in Wireshark. Okay, start capturing data on the interface. Start. Okay, start. This is the button. Start capturing packets. A window prompts you to save the previously captured data before starting another capture. It is not necessary to save this data. Click Continue without saving. Okay. Continue without saving. With the capture active, ping the following 3 website URLs from a Windows command prompt: yahoo.com, cisco.com, google.com. When you ping the URLs listed, notice that the domain name server DNS translates the URL to the IP address. Note the IP address received from each URL. Okay, ping yahoo.com, www.yahoo.com. Okay. Okay, look at here. The domain name server DNS translate the URL to an IP address. www.cisco.com. And finally, www.google.com. Stop. Examining and analyzing the data from the remote host. IP address of yahoo.com. Okay, this is the IP address of yahoo.com. This is the IP address. And also you can see here the destination IP address of the first line. This IP MAC address of yahoo.com. Select here the first line, select at the middle section on Ethernet the destination, this MAC address B0, B2, 8F, C2, 74, BB. Okay, this is the MAC address for the destination. Select value. So color black. Okay, this is the MAC address. And the IP address of Yahoo. This is the IP address, the destination IP address. Okay, or this 7230 copy value. You can expand this Internet Protocol version 4 and the destination IP copy value. Okay. IP address of cisco.com. Okay, this is the IP for Cisco. This may vary in your case. 23.202 is this. This up here. This line. Go to Internet Protocol version 4 and down here the destination copy value. The MAC address for cisco.com and Ethernet to the destination MAC, this copy value. Google. This is the IP address of Google, 172 in my case, and is down here. Okay, 172 as the destination. The source is my IP address of my PC, and the destination, the IP address of google.com. go to Internet Protocol version 4 and the destination, copy value. In the MAC, on Ethernet 2, the destination MAC, copy value. Okay, look at this. The MAC address in all cases is the same. B0, B2, AF, C2, 74, BB. But the IP addresses are different. What is significant about this information? MAC address will be the same for all three locations. It is the physical address of the default gateway LAN interface of the router. Okay, the LAN interface on your router. That is the MAC address for the three locations. The MAC address of the LAN interface on your router. How does this information differ from the local ping information you received in part 1? A ping to a local host returns the MAC address of the PC NIC, network interface card. A ping to a remote host returns the MAC address of the default gateway LAN interface. Okay, and for example, ipconfig all, and this is for my Ethernet adapter. Maybe you are using Wi-Fi adapter, but in my case it's Ethernet. And review this default gateway, 192.168.1.1 in my case. So ping, okay, and start here capturing packets, continue without saving, then ping 192.168.1.1, my default gateway. In your case may vary, but ping to the default gateway, select the first line at the top section, and on Ethernet 2, the destination MAC is B0, B2, AF, C2, 74, BB. So you know what is the MAC address. Okay, and that MAC address is the same as the three locations, the three remote locations. Okay, also you can use ARP option A command, and you will get the MAC address of your default gateway. Reflection. Why does Wireshark show the actual MAC address of the local host but not the actual MAC address for the remote host? MAC addresses for remote hosts are not known on the local network, so MAC address of the default gateway is used. After the packet reaches the default gateway router, the layer 2 information is stripped from the packet and a new layer 2 header is attached with the destination MAC address of the NetHub router, allowing ICMP traffic through a firewall. Create a new inbound rule allowing ICMP traffic through the firewall. Okay, go to Control Panel, System, Windows Defender Firewall. Turn Windows Defender Firewall on off is disabled. So for this, you need to turn on the firewall in both cases for private and public networks. Enable on green both. Okay, now it's activated. Okay, follow all these steps. Go to advanced settings, inbound rules, new rule. Okay, custom, next. Go to protocol and ports on the left, and protocol type ICMP version 4, ICMP before. Next, which local IP addresses does this rule apply to? Any IP address and any. Next, allow the connection. Next, for domain private and public. Next, and choose any name. ICMP before the dash in, for example, finish. And this is the rule here, up here. Disabling or deleting the new ICMP rule. After the lab is complete, you may want to disable or even delete the new rule you created in step 1. Okay, select this, the rule and disable rule. Now it's disabled, or also you can delete the rule. Thank you very much.